The water consumption in Malaysia has been increasing steadily since 2003, mainly influenced by the rapid urbanization process, population growth, industrial growth and low water tariff. The largest proportion of consumption was through domestic use, where the average per capita consumption was highest in 2020. States like Selangor, Johor and Penang were the states which had the highest consumption level due to the busy population density and economic sectors, but systematic problems of share water meters, incorrectly classified uses and high non-revenue water through leak and theft, is aggregated real demand and consume efficiency. The National Water Service Commission (SPAN) has been able to achieve some success in the past few years in its efforts to bring about better management of water. By 2022, the average domestic water consumption continued to decline as a result of the public awareness campaign, leak repair programs and policy change. Despite the still existing difficulties, particularly with the infrastructure and cost, Malaysia is gradually approaching more sustainable use of water.
For linear model, as we know, the formula of linear model is y equals to a plus bx. We must follow this step to solve this equation. First, we represent the matrix of the above system like you can see in the slide. After that, we need to find the value of A transpose A inverse and A transpose B to use in the formula X. Then, we will get the equation of the best fit line as you can see in the slide. Now, to find the error vector, we need to use the equation E equals to B minus AX and result is shown in the slide. We can continue to find the error magnitude by using the formula and the answer is 564.629342. This is the graph of best fit curve against each observed data and the graph of error vector against X values.
Now, we move on to the quadratic model of the data. For this model, the general equation is y equals to a plus bx plus cs squared. After substitute all independent and dependent variables into the equation, we got ax is equal to b, which represent the metric of the system. Then we can derive the normal system by calculate that a transpose multiplied by a inverse and x is equal to a transpose multiplied by b, and we get the least square solution by making x as a subject. We are able to find the equation of the best quadratic curve with the solution. After that, we need to calculate the list of error vectors by using the formula E is equal to b minus ax, when we got the error magnitude of the model as 563.4253 by using its formula. From this equation, we could get the best fit curve of the quadratic model against observed data and the graph of the error vector against the x value.
So our third model is a cubic model, which is represented by y equal to a plus bx plus cs squared and plus dx cubed. So our A model is 20 by 4 matrix and B model is 20 by 1 matrices. So first we need to find A transpose. After we find our A transpose, we can multiply A transpose with A. So we get this answer, and then we inverse the answer to proceed to our next step. So the second step is we need to multiply A transpose with B, and then after we find our A transpose with B, we just multiply A transpose A inverse with our A transpose B. So we find our X. So to find the model, the point in the graph, we need to multiply A with X, with our X we just found just now. So in order to find error, we need to minus B minus AX. So we find our error, and all of this is our error. So the last step is to find error vector. So we sum all error we we square our all error, and then we sum it and we square it. So we find our error vector, which is 468.7102. So we finish with our first procedure. So we plot the graph. So this is a graph for our cubic model versus original model. And on the right is our error graph.
So, we can conclude that the cubic model was the best fit curve that gives the best approximation in this case because it has the minimum error in terms of its magnitude.